Today we're going to take a deep look at how a jet engine works. Have you ever wondered how a massive airplane can fly through the sky at such high speeds? The answer lies in the jet engine. It is one of the most important and fascinating inventions in modern engineering. The basic principle behind a jet engine is the generation of thrust, which is the force that pushes the aircraft forward. This thrust is produced by taking in air, compressing it, mixing it with fuel, igniting it to produce high-temperature, high-pressure gases, and then expelling those gases at very high speed. This entire process is continuous, meaning it keeps happening as long as the engine is running. Let's start with the air intake stage. Air enters the front of the jet engine. As the airplane moves forward, air naturally flows into the engine. However, this airflow is not random. It is carefully guided and controlled to ensure smooth entry into the compressor. If the airflow becomes unstable, it can reduce engine efficiency. Next is the compressor stage, which is one of the most critical parts of the jet engine. The compressor consists of multiple rotating blades. As air passes through these blades, it gets compressed gradually. This means the pressure of the air increases while its volume decreases. This process follows the principles of thermodynamics and prepares the air for efficient combustion. The compressed air then moves into the combustion chamber. Here, fuel is added. Jet fuel is typically a kerosene-based fuel. It is sprayed into the compressed air as a fine mist to ensure proper mixing. This mixture is then ignited using an ignition system. Once ignited, combustion occurs, producing extremely hot and high-pressure gases. The temperature in this stage can exceed 1,000 degrees Celsius. These hot gases then move into the turbine stage. The turbine also contains blades, similar to the compressor. However, in this stage, the energy from the hot gases is transferred to the turbine blades, causing them to spin at high speed. This rotation is connected to the compressor through a shaft, meaning the turbine powers the compressor. In this way, the engine sustains its own operation by recycling energy. It's important to note that the turbine only extracts part of the energy from the gases. The remaining energy continues into the exhaust stage. In this final stage, the gases are expelled out of the back of the engine at extremely high speed. This is where thrust is actually generated. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. When the gases are pushed backward at high speed, the engine, and therefore the airplane, is pushed forward. This is known as jet propulsion. The efficiency of a jet engine depends on several factors, including air temperature, pressure, fuel quality, and engine design. For example, when the air temperature is high, air density decreases, which can negatively affect engine performance. There are different types of jet engines, such as turbojet, turbofan, and turboprop engines. Modern commercial airplanes mostly use turbofan engines. These engines have a large fan at the front, which allows a greater volume of air to pass through, improving efficiency and reducing noise. Safety is also extremely important in jet engine operation. Parameters such as temperature, pressure, and vibration are constantly monitored. Pilots and engineers use this data to ensure the engine is operating safely and efficiently. Another important concept is the thrust-to-weight ratio. For an aircraft to perform efficiently, it must generate enough thrust relative to its weight. Modern jet engines are designed using advanced materials to be both lightweight and powerful. Jet engine technology has improved significantly over time. Today's engines are more fuel-efficient, environmentally friendly, and quieter than ever before. Engineers are also working to reduce carbon emissions and make aviation more sustainable. To summarize, a jet engine works by taking in air, compressing it, mixing it with fuel and igniting it, passing the hot gases through a turbine, and finally expelling them at high speed to generate thrust. This continuous process enables an airplane to move forward and stay in the air. Although the concept of a jet engine may seem simple, the science and engineering behind it are incredibly advanced. That is why jet engines are considered one of the greatest achievements of modern technology. I hope you learned something new from this video. If you enjoyed this kind of science and technology content, don't forget to like, share, and subscribe to the channel. Stay tuned for more detailed and interesting videos. Thanks for watching.